Hello everyone. Okay, so in today's video we're going to be going over congruent triangles and congruency in general. So what is congruency? So we say two shapes are congruent if they are exactly the same. So two shapes are congruent if they are the same. So for example here, I have two triangles here. The left triangle has sides 5, 6, 10. The right triangle has sides 5, 6, 10. Only difference, the right one flipped upside down. They are the same triangle, just different orientation. So therefore, we can say they are congruent with each other. So if we're saying something is congruent, we can use this symbol here, which is like a triple stacked equal sign. So that shows congruency, right? So that just means the same shape. The same shape. Basically, that's what congruency means. So that goes for any shape. But in this video specifically, we're talking about congruent triangles. So when we're talking about congruent triangles, we have 4 rules for congruency, right? So the first rule is SSS. All sides are the same, right? Then we have SAS, where they have 2 sides the same, and the angle between the 2 sides are the same. Then we have ASA, which is we have 2 angles are the same, and the side between them are the same. And then finally we have RHS, which is just we have a right angle, hypotenuse, and one other side that is the same. And that's it. There are our only 4 rules for proving a triangle's congruency. And before you ask, no, we don't have a rule for angle A, angle side, side. Get over it. Grow up. No. Yeah, no, so we don't have a rule for angle side, side. So, yuck, yuck, yuck. Anyway. So, we have the 4 rules. Side, side, side. Side, side, angle, and right angle, hypotenuse, side. So, it's really important when we're proving congruency, yeah? If we want to prove two shapes are congruent, we need to write down our steps, and then we need to write down our congruency rule at the end of it. So what do I mean by that? I will show you some examples here. So, ABC is an isosceles triangle in which AC is equal to BC. DE are points, and BC and AC such that CE is equal to CD. So I have 2 triangles in here. Prove triangle ACD and BCE are congruent. I have these triangles stress me out. It stress me out. They're all mixed up together. So I am best now is to separate them. So I'm going to separate out triangle ACD. So it's always best if you have shapes like this with triangles on top of each other, draw them out. Now I have triangle BEC. Get that? And extract it out. Gorge. So B, C, E, A, C, D. So let's look here. Proved. Let's start labeling some bits here. So I know AC is equal to BC. So AC. So AC is equal to BC. Gorge. That's given to us. I also know CE is equal to CD. So CE is equal to CD. So I've nearly proven congruency here now. I just need either to prove AD is equal to EB, or I just need to prove that these angles here are the same. So let's have a look here. When I drew over my shape here like this, what do I notice? The overlap, yeah? And the overlap here. They both share this common angle. They both share the angle C. Right? So now I've proven congruency from my diagrams, but I need to put this into words. Right? So they both share that angle there. So let's put this into words. So I know AC is equal to BC. That is given to us. So I'm going to write given if it was given in the question. CE is equal to CD. Again, that was given to us in the question. And then finally, I know angle ACD is equal to angle BCE. right? Because that's a shared angle. Therefore, triangle ACD is congruent to triangle BCE under SAS, so side, angle, side. So therefore, that is how you write out the proofs for congruent triangles. So let's look at another question here. So DEF is an equilateral triangle. G lies on EF. DG is perpendicular to FE. Prove DFG is congruent to DEG. So I want to prove that DGF is congruent to DEG. This here. Well, first of all, the question, equilateral triangle. This side is equal to this side. I also know DG is perpendicular. So therefore these two angles are right angles. And also they share the side DG, don't they? So I can use my rule, or HS, right angle hypotenuse side. So let's get this into words. So I know DE is equal to DF because it's an equilateral triangle. DG is a shared side. And finally, angle DGF and angle DGE are both 90 degrees. Therefore, triangle DFG is congruent to triangle DEG under or HS, so right angle hypotenuse side. That's it. That's how easy these questions are. Once you've proven one of them rules, you just write it down and there's your full marks. Let's have a look at another question here. So in the diagram, the lines CEDF intersect at G. CD and FE are parallel, and CD is equal to FE. So prove the triangles CDG and EFG are congruent. So CDG and EFG. So EFG, CDG. So in the question, it gives us these two sides are equal. Also as well, these sides are parallel. So ding, 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 ding. I am seeing parallel lines and a transversal. So what am I thinking of? I am thinking of my angle theorems. So I know for a fact, ladies and gentlemen, this angle is going to equal this angle because it's alternate angles. Maybe I should probably use a different color than yellow. Use green, maybe. You see that? Hopefully. And I know this angle is going to equal that angle. It's about alternate. So we need to write this down. So I've now just proven this under ASA, right? But let's get my proof down. So I know CD is equal to FE because that was given to me in the question. I also know as well angle CDG, so this green angle here, is equal to angle GFE, alternate, so alternate angles, and angle DCG is equal to angle GEF, because alternate. So therefore, triangle CDG is congruent to triangle EFG under SAS. And that's the rule I proved it under. So I proved my first thing, my second thing, my third thing, and now I say what rule I used. And that's it. That is as hard as it would get. And sorry, no, that's a lie. Not under SAS, under ASA. Sorry, angle, side, angle. And that's it. The video is done. I hope this was some help to you, ladies and gentlemen. And I'll catch you guys later. Bye.